guys, I'm going to go over the last two problems we did in class today. So we talked about probability being independent. What does it mean to be independent? One does not affect the outcome of the other. So probability of A and B is equal to probability of A times probability of B. I always say think of this as probability of getting heads on a coin and getting number 3 on a dice. Just because you got a heads on a coin doesn't increase the chance of getting 3 on a dice, so they are independent events. In this case, you have half times 1/6, which is equal to 1 out of 12. What does it mean to be mutually exclusive? Mutually exclusive means disjoint, which means they have nothing in common. So probability of A and B, where they intersect, has to be equal to 0. So on a Venn diagram, you have a probability of A and probability of B, but they do not share any common sides. So let's look at a problem. You have probability of A is half and probability of B is 1/3. You want to find the probability of A or B. If A and B are mutually exclusive events, that means they have nothing in common. So probability of A and B will be 0. So given this formula, which always works, right? Probability of A or B is equal to probability A plus probability B minus what's in common. But in this case, since it is mutually exclusive, this is equal to 0. So you're just left with probability of A, half, plus probability of B, 1/3, which is equal to 5 out of 6. How about if A and B are independent events? If A and B are independent, the only information that you're getting is that probability of A and B is equal to probability of A times probability of B. So events are independent. So I know probability of A and B has to equal to probability of A times probability of B, which is going to give you 1 out of 6. So then now use the same equation in blue to figure out the rest. We have probability of A or B is equal to probability of A plus probability of B, again, minus what's in common. This time, what's in common, based on the definition of an independent, is 1 out of 6. Therefore, you have probability of A is half plus 1/3 minus 1 out of 6 is equal to, this already know is 5 out of 6 minus 1 out of 6 is equal to 4 out of 6, which we can reduce to 2 out of 3. Next question is this guy over here. You have a probability of, again, A and B is equal to probability of A plus probability of B minus what's in common. This is always true. We also talk about in class the conditional probability is that the probability of A given B is equal to probability of A and B over probability of B. So let's look at a question. You have probability of A is equal to 2 out of 5. Great. Now probability of B given A, this is something we can rewrite. Probability of B given A is equal to probability of B and A over probability of A, which is equal to 1 out of 3. Therefore, if I simply plug in what I know from probability of A being 2 out of 5, I have probability of B and A divided by 2 out of 5 is equal to 1 out of 3. Therefore, probability of B and A is equal to, you need to multiply by 2 out of 5 on both sides to cancel it out. So 2 out of 5, that would make it 2 out of 15. Apply the same logic for probability of B given A naught. Probability of B given A naught is equal to probability of B and A naught over probability of A naught, which is equal to 1 out of 4. Given the probability of A is 2 out of 5, we know that probability of not A has to be 3 out of 5. So we have probability of B and A naught over not A, so 3 out of 5 is equal to 1 out of 4. Multiplying again, 3 out of 5 on both sides, you are left with probability of B and A naught is equal to 3 out of 20. Now we are going to combine these informations together on a Venn diagram. So we have probability of A, probability of B, and we have a universal set. The sample space is a box. So we already solved that probability of B and A, that's what's in common, is equal to 2 out of 15. So that this area over here where they share is going to be 2 out of 15. Given that probability of A is equal to 2 out of 5, probability, if I let this side to be small a, probability of A is equal to A plus 2 out of 15. So probability of A is 2 out of 5 equals to A plus 2 over 15. So subtracting 2 over 15 on both sides, you have 2 over 5 minus 2 over 15 is equal to A. So common denominator of 15, multiply 3 on both sides. So 6 minus 2 is equal to 4. 4 out of 15 is equal to A. So this area, I'm going to change my color, A, into 4 out of 15. All right. So let's look back and what the question was asking. You have probability of A, 2 out of 5, and you had to find probability of B. All right, let's see what we can do with this information that we found. Probability of B and A naught. Probability, again, with B and A naught is the area shaded right here, not including the common area. So that area in itself is 3 out of 20. So let's look. Probability of B is 2 out of 15 plus 3 out of 20, common denominator of 60, multiply by 4, 8, plus 9, that's going to give you 17 out of 60. Probability of A and B naught, A and B naught. Probability of A and B naught is going to be the area A and B naught is going to be right over here. Not including, again, in this common area. So that's the area we found for A. So that's equal to 4 out of 15. I hope this was helpful, guys. Bye. Have a nice weekend.